Hi everyone, here is the third and final part of our beam effect tutorial. In the first part we covered the beam effect, in the second one we explored the cast animation, in this third part we will create the anticipation effect and see how to render it with Redshift. As you asked, I am going to record an extra tutorial to explain how to render these particles with Mantra. Hope you enjoyed this last tutorial and the previous ones. Now let's jump into the final part. Before we start, I want to talk to you about our new support page and our weekly live stream. This November of 2020, Doxia made 3 years old, and I decided to start something cool. As a result, I have started Doxia's weekly live stream every Thursday. In these live streams, I am going to explore Houdini and Unreal, develop visual effects, develop CGI scenes with real-time render, and help the community as much as I can. If you want to support Doxia Studio, you can do it with Patreon or Jamie, and now we have our own donation page and merchandise. You can donate or buy Doxia's original merchandise, and by doing so, you are supporting this channel. With your support, we can keep doing these tutorials and content to help the community and explore new skills to improve our work. So at the end of the second part, we end up like with this effect, okay? This cool effect. I just did a few things, adjustments. I added more particles to each effect and then file cache everything so we can have better results on the render. Okay, so on the cast, I did a few things. I grouped them, okay, so we can give different attributes to each group. Okay, I added more particles because I want to cache and have better results on the render, and then file cache each system. Okay, this is from the ring, and this is okay. Okay, so that's it. So let's start the third part. Let me show you first the flipbook, what we got. Okay, this is our effect. Okay, pretty cool. So before we start looking at the render, we are going to create some anticipation animation before the beam cast. Okay, before the beam skill, because during the first second, okay, the first 30 frames, we don't have nothing, and that is not good. Need some anticipation. So let's start doing that. Okay, let's see the animation time. Pretty cool. So let's place a geo. Again, we are going to use a PopNet. Oops, not this geo. Okay. This one will be the anticipation. Oh, yeah. So let's dive in. Let's put here. Okay. Close that. Polygon. Fixed frequency. I want to see my wizard. Don't need to see the other skills. Just want to see the wizard for scaling. Okay. So let's build this up. Let's put a transform. Let's push a little bit up. Scale it. Go with 8. Okay. We are going to emit particles, okay, on this sphere, and I don't want to emit them on the floor, so let's cut the sphere. Let's put a box, okay. Let's put the box on the floor. Remember, we copy this. Place relative reference. Up to 0. Okay. You want divide this by -0.5. Okay. So it is always on the floor, even if I increase this to 5. But going down underground. Okay. So let's go with 20 by 5 by 20. Okay, cool. And let's boolean this. Can try boolean. 2 O's. So let's wire both geometry. Okay, very cool. And we need to increase. Okay, so we have our sphere. I'm not using like the lab sphere, for example. So there is a labs. Okay, lab sphere generator. We could use this one. Okay, 8. We could use this and cut the sphere. Okay, already have the hemisphere. But this way, not everyone has the side effect slabs installed. But this way, I can push this a little bit up. So we have more a bubble and not a hemisphere. Okay, off of a sphere. Okay, so this way we have the sphere, and let's place a null. Keep things organized and call it base geo. And then let's start our popnet. Not poopnet. Popnet. Okay. Something is wrong with me today. Okay, popnet. And here we have our particles. Very cool. So let's type in. What do we want? First, I just want to emit particles before frame 30, right? Because at the start of frame 30, our beam starting after 30, okay? And we just want 5. Okay. So right now they don't do anything. Let me turn it right. Right now they don't do anything. Let me increase size. These. Let's go press D, geometry, and points. 10. You can see them. Okay, so right now they are not doing anything. So we need to add some velocity. And what I want is them to go to this point, right? So I want these particles like to be energy. We are gathering energy from our surroundings and move them and track them to this point, okay? We can use that multiple ways. I think there is an attractor, pop attract. Okay, we can add these, or we can use VOPs. This is the simple way. You don't need me to explain this. You put your goal where the attraction is, to attract the point attraction is, the position, and they will do the things for you. But I want to use VOPs, so you can start using math, programming logic to start Houdini. Okay. So let's do the tricky way, the math, so you can understand the logic behind. So we have our current particle position, right? And we want them to attract them to a position, okay? Remember, we could do that with vector math, okay? Okay, so let's see the math. And we are going to see in, okay? So we have the point A. This is the current position of our particle. And we have a goal, the position B, okay? So A, the vector something like 3 and 8, okay? We are going to see in 2D, in 3D just having another coordinate, okay? And we have our goal, the B. And our goal is something like 12 and 3, okay? And what we want is to know this vector, okay? Vector. This will be our velocity. So our velocity is something simple as our goal, the point B, minus our current position, the A. So let's do this in VOPs instead of using the pop attraction node. So we have our current position. Let's put a parameter. Let's call it goal position. Okay. And like I said, we just need to subtract. So we have this, the point B, subtract the current position. And now we have our velocity. Pretty simple. So now we have our velocity, and let's see what this got. So our goal position for now, we need to change one thing. It is a float, 3 float vector, okay, 0, 0, 0. And we create a parameter because this way, outside of the pop-up, we can control the position here, okay, that vector, our goal vector. So right now, if I press play, you see our points go to the goal position, okay, because each frame we are adding that velocity. Okay, pretty cool. So one thing I want to do is, so here, is multiply or change the force of that velocity, okay? So easy way is like put a parameter. This way is a float, and let's go with attract force, okay? So we know what we are doing. Let's default be 1 and just multiply, okay? By both, and this is the, so we have this attract force mult. So in 1 it's the normal as we did before, but this way if I increase like to 10, you'll see the force will be stronger, right? Like the force of this attraction. And if I multiply by 0.5, we will have half of that velocity of that force. Okay, pretty cool. So let's change this to 4, the force, okay, that they will go faster, will go faster to the goal. And we need to kill them because they are staying in the goal position, okay, for along all the animation. So let's change the life. So let's go with 0.75 and variance, maybe less. Oops, less. That 0.6. Okay. So you will see that they will start dying. Okay, close to that. Maybe we want to have a little bit more. So we cast here and we keep getting it. And we can increase the number to 15. Okay, cool. And we need to change this goal position, okay, because our goal position will be this one, okay. Right now we are gathering to the center, okay, to the origin. So one way to know the position is just, as you remember, for example, go to the cast, pick up this transform, okay. Oops, yeah, it is loading. Come on. I'm loading all the caches. Okay, let's go to this transform. Remember, we put the animation into position and we want this little point. On this transform, let's copy parameter, right click, copy parameter, these values. And on our anticipation, let's use those values. Right click, paste values. Okay, so right now they will go there. Okay, very cool. So now I want to emit other particles, okay, on these points, these lead particles, okay. So one way to do that is to use replicate, pop replicate. We could use another popnet, but we can do everything inside of this one. So let's go here and wire it like this. If you wire like this, these points that have been replicate from this one, okay, they are not going to be how do you say in English, move or affected by this pop-up, okay. So right now these replicate are just emitting particles same as this one, as this pop source, and they are emitting in a sphere, if I am correct. Yeah, they are emitting in the sphere, that's why I'm doing that. Let's put a pop color so you can see the difference between them. So this one will be yellow, so you can see them better. You have that blue here, okay, that white, sorry, that is our original, and we are emitting particles. And again, they are emitting exactly the same as this pop source at that frame, okay? So we need to kill the velocity and just emit particles without any attribute. So let's go here on attributes. Let's delete this asterisk because we don't inherit any attributes. Okay, we don't want initial velocity, nothing. Okay, just the position. And we still use inherited velocity. So let's go to set initial and put it 0, 0, and 0. Okay, let's go again. And now we have the particles. Pretty cool. So now let's do the same as we did on pop source and let's kill them. Maybe they want to be have less life. Okay, let's see if that kills them. We need to reset. There's a little bug here. Sometimes it doesn't reset the cache. Let's see if now it works. Okay, so everything is all right. We are killing them and they are being we are replicating source, pop source, from our pop source. Okay, so now what do I want? I want to add a little turbulence to this replicate. Okay, so let's again go with our pop. Let's add some turbulence noise to our velocity. Okay, so let's wire the position into the position. Okay, let's add the noise to a velocity. Okay, so right click now and go to VexVop, create input parameters. Let's do one thing, signature change to 3D noise. So now we have noise V. Okay, noise velocity. Let's see what is going on. So we are adding some velocity. Let's go to change our timeline to frames, maybe 45. Okay, we don't need to see all the animation now. We just want to loop this while we control. So the frequency, let's increase this. Okay, maybe go to something like that. I want maybe sparse convolution, and I want more amplitude, less roughness, and let's see what we got now. Okay, that's cool. Maybe I want more amplitude. That's way too much. Okay, cool. And I think we still need to add a little bit of our, let's go, attraction force. We need to add a little bit of that attraction to our replicate. So let's wire this like this. Okay. And right now, let's decrease this to 0.5, maybe. Maybe that's way too much. And we lost our noise velocity. Okay, because we are just replacing our velocity by our attraction. So what I want to do is pick the previous one, okay, and add this attraction. Okay, so we want to add this attraction force to our previous velocity, okay, because that velocity already have our noise. Okay, so this way we might still have our noise and we are attracting a little bit to our goal position. Okay, let's change the geometry. Let's go back to 2, something like that, and maybe I want less frequency. That's cool. That is pretty cool. Okay, so now I think we should add a little bit of colors. Okay, and I want to give colors to our particles. Okay, so let's put a pop-up, not a pop-up, a point pop. Okay, maybe we are going to use, let me think, we're going to use life color of life. So let's go pick up our cast and let this think a little bit, get all the cache. Okay. So let's pick one blue color over life. Okay. Just select this node, copy, go up to our anticipation and paste. Okay. So let's check this. So we are using our age and life. Okay. So we put a fit, color over life, and put this to color. Okay. Go up and check that. Okay. Pretty cool. And I want to do one little thing, is to change this shape. I think it's way too big. Okay, so let's go back. Okay, pretty cool. And I think that's cool. Maybe I want to change one thing on the birth here. I was trying to avoid those gaps, but that's okay. That is okay. We don't mind that. So we have our bluish, okay. Pretty cool. And let's add the pink version, okay. So here, let's change a few things. Let's change the seed. We want less pink ones, okay, and everything is the same. And on this one, I want a different color. So let's go here. Let's pick the pink. That is cool. Control C. Let's go back here and press D. Delete this one. And let's merge. Okay, so now we have both colors. Okay, that is pretty cool. And let's check this out, everything together. Let's increase the timeline again. Oop. And cast. Let's turn on the cast. And I'm going to do a flipbook with all those three effects before we jump into the redshift. Okay, this cast effect is really cool. So I'll be doing a flipbook and be right back. Okay, so here is the flipbook. I did a little change on our beam. I scaled it a bit, so it is more aggressive, more powerful. So as you can see, our anticipation fills up the beginning, and it's a little bit better. Okay, so what I did was on the beam, on the last transform, I changed the scale to 3 to 3/2. Okay, so it has more powerful. And let's go to the render. I think that's everything. So let's save and Shift S, and let's go. Let's start with redshift. Okay, accept. And I'm going to switch. I don't think, yeah, I updated the Houdini, so I lost my layout. So okay, let's go. What I want to do, I want to divide this with top and bottom, and this one, okay, this our object. Okay, I do this. Okay, we have our parameters, and here I want to fit top and bottom. So we have our object. This will be our chop. Okay, and I want to split again, and this will be our out. Okay, so we can control everything, and everything is on our viewport. So let's save current desktop as docs. Enter. Save. What happened? Something happened. Hope everything is okay. I don't know what is going on. Okay. Let's go back to our background. That So let's go to frame 60. I think that is where the particles, when the particles are more power. Okay, so let it cache everything. Okay, pretty cool. Let's change the geometry pixels, points. Okay, look like pixels. But this way we can add alpha. And on our shop, we are going to create our Redshift node. So let's go Redshift. Let's call it areas particles. Let's go particles dust. Okay, and let's go here and place a material. Oops. Tab material, Redshift areas material. Okay. Link out color to surface. Okay. And let's leave like this for now, like this for now. Let's alt drag, and this one will be the lead particles. Okay, so we have the dust, the lead. Let's add a material for our wizard. Okay, yes, wizard, and we want to have a floor. So let's go here and place a floor. Okay, pretty cool. And let's place a grid. Okay, let's call it floor. Christy. Okay, cool. So our wizard will be the areas wizard. Let's go to shop, areas wizard. Okay, our floor will be our areas floor. Okay, wizard will be something like this. I want the reflection to be this. Okay, now our floor, I want this to be dark. Okay, with a bit of roughness. Okay, pretty cool. So, what do we want? Maybe we can just have one particle. But I want to show you how we can add different colors to our particle. Okay? Different materials, sorry, to our particles. That is our beam. Let's go to our beam effect. Okay, so this is the one. Did I have groups? No. So let's change this. So let's group this. So this, let's put a point group. This is points. And I want this to be the beam shell group. Okay. And this alt drag. And this one beam turbulence. Okay, so this one beam turbulence group. Okay, pretty cool. So now we want to add p-scale. So we need an attribute called p-scale to change the scale, the size of each particle. So let's put a point triangle. This is the easiest way. Okay, so we need to create a p-scale attribute. This will be by 0.01. Let's go with that for now. Okay. And what do we want? And we want to give different materials. Okay. So I think we have materials. Okay. Let's put a material node. And on this one, we want, how come I don't have groups? Points. Okay. I have points. Let's see here. I have point groups, beam shell group, and beam turbulence. Okay. How come I don't have? Oh, because it's not a primitive, it is a point attribute. Okay, so on material change to point attribute, let's change this to beam shell. So it is the shell. Remember, we have this turbulence and we have a shell inside. So this one I want to be the particles lead. Okay. Cool. And on the other one, on the second one, will be the turbulence, and I want dust. Okay, pretty cool. Something like that. Okay, they lost the colors. And okay, that is everything here. Let's go to the cast effects. Come on, man. Move. Okay. So, I want my rings to be one side and the others to the other side. So, let's go with a point triangle. So, on this side, I want my P scale to be 0.01. Okay. Points. This one. This one I want to be really low. Okay. So these ones is all the other ones will be smaller than the rings. Okay. Remember we have these noisy ones and we have, let me try to zoom. This is starting to be really heavy for my computer. And we have those rings, remember? So the rings will be bigger. The particles from the rings will be bigger than the dust. Okay. And I want again a material. Maybe it is. Let me think. Because we have a lot of groups, but that's okay. So let's place a material. And this is a point on the group ring. Ring points 1. Oops, this one. Okay, on these groups, let's go with the lead. Okay, on the next one, as you can see, those are the rings. Very cool. On the second one, we want the casts. Cast. Second or third one. That's okay. This and we want them to be the dust. Accept. Okay. Everything will turn black. And I want to do the same here. Okay. On the anticipation. On the anticipation, we didn't put point groups, but you will see that is easier to do. So let's see if my computer wants to work. Let me save before it crashes. So let's go to frame 20. On. Move. Okay. I want to add a P scale. Oops. I need to put a triangle and then add. So on this one, scale of 0.01. Okay, cool. But I want this P scale to be on the lead particles. So I know the lead particles are the source first input. Okay. Let me go inside this popnet. So when you emit particles, we have the pop source. Okay. This will be from source first input, and then we have the pop replicate. Okay. And as you can see on our point groups, we have both. We have the pop replicate and the source first input. This way, we are adding a P scale to the source first input, to the lead particles, in other words. And if we wire another P scale, this time smaller than the previous one, and this time we want to be the pop replicate. Okay. So right now, replicate will be this P scale and the lead particles will be bigger. And we want add material again. This time we want the lead particles to be the lead and our replicate will be the dust. Okay, pretty cool. So now everything is black. So let's go up. And we need to do one thing in the materials. Okay, so in the materials, right now our material is nothing special, right? So let's add a point. I think it's a point attribute. Redshift point attribute. With this node, we can go and pick any attribute that we have on our geometry, right? If we come here, we have a lot of point attributes, okay? Age, CD, depth. So we can use any of these point attributes to control anything here, okay? It should be a 3D vector, but okay. So we want to use a CD attribute. We want to use the previous colors, the colors that we already have in our particles, right? So let's use this 3D float vector called CD. Let's go to the particle attribute lookup. This is kind of wrong, because when you press tab, you search for a point attribute, but when you click and place, it changes the name to particle attribute lookup, but it's the same, okay? So in the attribute name, let's use the CD. It is our previous color that we created with our VOPs, okay? So right now, I don't know what we are going to use, but we are going to use the diffuse color, okay? And on the overall, we are going to use the emission color, okay? I'm not sure if we are going to use emission or not, but let's wire both. For now, emission is turned off. And we want to delete the reflection, because we don't want any reflection. If we turn this off, we are saving any process time. And we will do the same for our particles lead, okay? Again, tab, right point attribute, right CD as our attribute name. Let's go to our base properties, wire to the diffuse, and on our overall, let's wire to the emission. Okay, that is pretty cool. So right now, let's go up, and we have all the materials we need for now. So on our out, we need to place the redshift. Instead of going by hand, let's go to our redshift tab. If you don't have the redshift here, let's press plus shelves and add your redshift. Okay, so this is your tab. Just press on this first icon, okay, and it will create the nodes for us. Okay, pretty cool. So on the redshift drop, I want to change a few things. I'm not the biggest expert on this, but on the samples, I normally use 8 and 64. Oops, 64 to start. Okay, on global illumination, I go with brute force just to start with 6 by 512. This is my starting point. If I need some tweaks, then I increase the samples or change here the global illumination engine. Okay, normally I go with point cloud if I need, but to start, this is my starting point. Okay, and I think that is pretty much. So maybe I will add one little light. Okay, let's add some dome light. Just no, not a dome light. Let's add save or it crashes. Let's put a light here. Yes, light. Something like this. Okay, something like this. Let's increase size. Go to native camera. Where is it? Let's increase the size. Light. Where is it? Let's go 10 by 5. Okay, something simple like that. Let's go to 5 for now. And let's place a camera. So let's go to frame 60. Okay, and we can see all our skills. I think this is all black. Okay, computer is starting to get really slow now. something is heavy. Maybe by using Redshift and I'm recording, so everything is heavy for my CPU and GPU. So one thing that I'm disliking is everything is black. That's really hard to see, and that's because of our material node, remember? So let's jump in. Come on, jump in. Need to use the keyboard. So let's go here. Okay, put the blue tag here, two colors, but then let's select this one. And I think if you control click, you are saying that on the viewport, let's see this transform. Okay, but in the render, use this material. Okay, when it is purple on that tag, means that this is the render node. Okay, and let's do the same for the other ones. Let's go to the cast. Inside form, press Control click on that material. Okay, and on the anticipation, let's go to the merge and Control click on that material. Okay, so now everything is faster. Okay, that node is really heavy. So now I can move freely. Let's press the tab, camera, sorry. Let's organize this. I don't like this. Okay. Let's go to the camera view. Let's go with full HD. Now let's go with HD for now. Just see everything, and the camera go something like that. Okay, let's pray and see our first result with Redshift. This is super simple for now. Okay, and let's see how it looks. I think I forgot one little thing. That is really important. We don't see any particles on our render, right? I need to increase this for the but as you can see, we don't see any particles because I forgot one crucial thing, and that is really important. I had the materials and everything, okay? So, oops, the materials we had it inside, but we forgot to turn on render object as particles. This is really important because we need to tell the Redshift render this object as particles, okay? Because we are working with particles. Okay, so now let me switch the view to full HD because it was too small. Now let's see if we got it right now. Hope so. And I hope those material nodes are working. Because this is really heavy for my computer, I only used one material for the particles, one global material. But let's see if it works this way. Okay, that is cool, but we are not getting the colors. That looks cool with the only gray nodes. So, what is going on? We turn on the CD. We are using the materials. Let's see if we increase this. No, it does. I think the problem is that materials node. But let's see. Yeah, sometimes I'm trying new stuff for the tutorials, and sometimes they don't work. I need to do a little bit of research before. So let's do the simple way. Let's see if that is the problem. Let's go up and see if this way works. Maybe I'm using the wrong material node, because I know I used that in the past. Let's see. And it's taking way too much time. So yeah, I need to use another. Maybe instead of the material. Nope. I was trying to do that, but maybe I'm missing something. I'm passing by the attributes, right? CD, float. I'm checking if I'm missing something. Overrides use local variables, merge overrides. Forget that. Let's use always the dust. Don't mind that. Not enjoying that much. So let's delete materials in every node. Sorry about that. I was trying a new thing for the tutorial. If I find a solution, I'll post it. Okay. So right now, let's link a material. So let's use the dust. Let's change the name because now we don't need to. So delete this one. So we have the Redshift materials, particles. Okay. So let's again link this, and on this one, link this. Okay. Cool. And we have everything with particles, render object as particles. Okay, I hope this way, without that node, it will work. Sorry so much about that. I was trying a new thing, and sometimes things doesn't work. I'm missing something. So let's see now if we got the colors. Hope so. Okay, boom, pretty cool. So we have a lot of things going on. I right click and put always on top. So if I go to the Houdini, we still see the viewport. Okay. So let's tweak a little bit this. Okay, on the materials, let's turn off something like that. On the opacity, I know I want them to be a little bit with opacity. Okay, so we have more of these strings. Okay, pretty cool. See there, the strings. Increase this, maybe. Will it boost? Okay, something like that. That is cool. So what do I want? Let's go to 1 for now. Let's the bottom, link this here, and change the camera so we can see the looks, the different looks. Okay, that looks cool. So what can we do now? So we have those particles. That is cool. We have the dust. So this way we can control wrangle. So on our beam, every node has the same wrangle, as same p scale, but we can do the same as we did on the other ones. We have this group and this group. So let's, the bigger one, let's even change this to 0.05 and change this to use the shell group. Okay, and in other one, fire this, and this one we want to use the turbulence group. This one I want to be really small. The turbulence I want to be really small. So let's press IPR again to update everything, and let's see the result on that our beam. We are changing the beam now. So let's build the redshift scene, see how it goes. So as you can see, this is way different. Pretty cool, but I think we lowered that really low. So I want the beam to be higher. Okay, cool. That is cool. And maybe I don't want this to be so low. Like 0.5. Okay, and on this one, go with 4. 0.004. Let's see. Cool. Don't keep not in the right point. I'm not enjoying this much inside. Okay, that looks cool. And I think that's pretty much it. So we are adding different P scales to each group. On this cast, we could do the same. Okay. So on the cast effect. Oops. Okay. Did you see that white flash? My Houdini is. So on the cast effect, we are doing the same. So let's go here. So we have a different point angle P scale for our rings. So those rings have a different P scale than our dust. Okay. And our anticipation. Go 20. So we can see the anticipation on render. This is the only thing we didn't check. Here. See. It's taking too much to build. So this is our anticipation. Pretty cool. So now I'm going to show you how we can add like 3 cameras with 3 different views and angles of view, okay? And then adding ROPs so we can render everything in one go. And you can go to bed and render the different views instead of rendering one, come back, change the camera, and so on. So let's go to frame 60. Come on. Okay, let's place the camera in a nice angle. So this is one angle. Okay. Let's alt drag. Okay. So let's go to camera 2. Let's place another view, something like that. Really enjoy that one. It's cool. And let's add another one. Camera 3. And maybe what do we want here? Like this. I think that's the same as one. So maybe. Oops. On the floor. Something like that. Okay. So we have 3 cameras and 1 ROP. If we go to the ROP, okay, on the output, on the ROP, we can go to the main and we have the render camera. So what we need is alt drag this, select the second one, and here pick up the second camera, okay? And do the same. Let's increase the size of this up. So on the third one, let's pick the third camera. But if you press IPR, you will see that we are going always render the camera 1. Okay, let's go always on top. Okay, even if my viewport is on camera 3, we are still rendering only 1 camera. So let's wait for this to build. So this is the camera 1, right? And I want to check the camera 2 or the camera 3. One way to do that is on this IPR node, okay? let's link the ROP. So if now I link the ROP 2, okay, press accept, you will see that we are going to use the camera 2 now. And this way we can check, imagine if you have depth of field, you need to check each camera if they have the right parameters, the right depth of field. And this way you can check each camera. Just change the ROP on the IPR node, okay? So this is another one. I really like this shot, very cool. So let's close that, and we need to wire this, okay? And we need to do one little thing before. On the final part, we are going to go to the last, press there on that tag, and do this node and all inputs. So to link all the inputs, and do node by node and press render. If I do this, it will still render only the last node, even if we have everything wired. Okay. So one thing that we need to do is select all the three, and on main there is a little checkbox that we need to uncheck, and that is the non-blocking current frame rendering. So if I uncheck that and go here, current frame, okay, let's render this to this output. Let's change to JPEG so we can see this. Let's go to JPEG. Okay, so if I go now here, leave everything, just change this node to and all inputs, node by node, and press render. If we uncheck that little box, we will render every node. Okay, so as you can see, we are on Redshift hop 1, and it will render that frame. Let me go and open that while we wait, because my CPU is a little bit slow. And this little trick saves me a lot, because I leave my renders during the night and I render all the nodes I need. Okay, so let's go here, beam effects, and we are going to render on the Mixamo, on the render, sorry. And I'll be right back when this is over. So I finished the renders. Okay, I changed to HD to be faster. So as you see, we have the three renders. Okay, with just one click, they render three in one go. Okay, I hope you understand what you need to do with Redshift to render particles. So let's go sum everything up. So on the nodes, go to Redshift materials, render object as particles. Line the Redshift node, your material. Okay, inside the Redshift network, you add that point attribute. It calls particle attribute lookup. If you press tab, is point attribute. Okay, pick the attribute you want. In our case, we are just using the color, so add color. Okay, we are adding the color to the diffuse color and the emission. We are adding that attribute. Okay, and like we are working with particles, so you can add p-scale, and you should add p-scale and control the p-scale for each group. Okay, inside with a simple point triangle. You could not have a p-scale and control the p-scale here. As you can see, you can ignore scale attributes and control here, but that way you can add different p-scales for each group. Okay, simple as that. So we have our network Redshift material. Okay, and in our our ROPs, we have three to show you that we could render different angles. Okay, if you want to render the animation instead of render current frame, change to frame range. Okay, so you will use the frame range, and everything is okay. So Redshift, I start with basic samples, 8 and 64, and global illumination brute force, double brute force 6, global illumination bounces, and GI rays. If you want to understand a little bit about this, you can check the Grayscale Gorilla Redshift. I think they have a really good. You go open the YouTube. They have a really cool Redshift tutorials. It's for Cinema 4D, but the cool thing about Redshift is that it's the same for every software. So you can check these tutorials because they explain in depth what those attributes means and why you use these numbers and everything else. So I suggest to check these two tutorials. Okay, that's pretty much it. Hope you enjoyed this one, and if you have any questions, let me know. I'm going to do and record an extra to know how to render these particles with Mantra, and that will be our final part, a little extra because my patrons asked for that, but I'm going to do that this week. So hope you understand everything about Redshift, how to render particles with colors, and if you have any questions, let me know on the comments below. See you and have a nice day.